We're now going to turn our attention to the hydrosphere, and we know a little less about it, so we have less slides. Now, it's about 70% of the Earth's surface. Here's something that is interesting. The average depth of the oceans are 3.7 kilometers, and the average height of the continents is 0.8 kilometers. We are much, much deeper in the ocean than we are high above the ocean. And so that's kind of an interesting idea. When we describe the ocean, we have several different areas. And so you've got the land, and you've got the sea. And we didn't know much about under the ocean, and so what we called the bottom of the ocean, the deep parts, the abysmal plain. Kind of sounds like it's like there's nothing there. And we say it's a plain, we thought it was flat. We do know a couple of things. That around most continents, there is a bit of crust that is close to the edge of the ocean, and it's relatively shallow. Now, relatively could be hundreds of feet, okay? And it gently slopes for most areas that are along the coast, and then all of a sudden there's a continental slope that goes down to the deepest depths. And so you can be miles deep in the middle of the ocean. All right? And so those are the components: a continental shelf, a continental slope, and the abysmal plain. The more we look at what's under the ocean, okay, we do have places where it's flat and there's a lot of muck and mire and silt that is at the bottom. But quite often, there are a lot of different features that are under the ocean. There are a lot of mountain ranges and a lot of very deep valleys. Every so often, a mountain range will reach up above the ocean and we'll get an island. Many of them that we know are volcanic islands made from volcanoes. If we did drain the ocean, this is probably what we would see. You can see that we have a rough surface over the land because we know we have mountains and valleys. But under the oceans, we have the same mountains and valleys that are represented there. And so anything that is dark can be really deep trenches. So we have some trenches down in here. We have trenches over here. This area has the deepest trenches in the world. We actually have some trenches over here, which is why the military base in Puerto Rico was established. Very deep trench. They would have submarine warfare that happened because of how deep it was. You can actually see some of the continental shelf where it is still under the water, but it's relatively shallow, and then you can see it falls really deep, particularly. Here in the Gulf, really relatively shallow, only very deep in the center. And so the Gulf is really relatively shallow. And so you can see places that have continental shelf. There are places, though, that as things come together, you get a big trench, and so you can have places where there's very deep water. But you can see a lot of things. You can even see this large mountain range that is in the middle of the Atlantic Ocean that is there. So there's a lot of things that are found. One thing that was interesting is we found this around World War I and World War II. We found these mountain ranges under the ocean. Do you know why we found those mountain ranges under the ocean during those times? Submarine warfare. What we would use are sound waves, and we would, if it would hit a submarine, it would bounce back. Well, by using that, they were also hitting the bottom of the ocean and would reflect back up. And we actually found a lot of mountain ranges and a lot of topography. It wasn't just this flat surface at the bottom. And so that was the first time that we discovered what was under the ocean. All right, big thing about the currents. The currents are moving around energy that is absorbed by the sun, all right? There are two kinds of currents. There are ones on the surface, and then there are deep ocean currents. The ones on the surface are pushed around because of wind, Okay, and so the wind can make surface currents. These are the ones you have to watch out for if you are swimming, and riptides and things of that nature you've got to watch out for. The deep ocean currents are really the distribution of the energy that's absorbed in the water and moves around. And remember, wind did about 80%, water only did about 20% of moving energy around. They have convection currents. They make circles just like wind, but it's a little bit more complicated because the land masses get in the way, and so that affects, they can't make these nice circles because they run up into the land. So this animation is a wonderful example of one of the deep ocean currents in which a lot of energy is moved around. It is very similar also to the jet stream, in which it's a small area that is being pushed around, and that energy is being pushed. In the jet stream it's air, in the currents they are water. And so I don't teach everything by movie, but this is a wonderful example about what the currents actually might look like. Now, one particular current that we're going to look at is the Gulf Stream. The Gulf of Mexico is very warm, and so the water moves up the coast going to the north, above or beside America, and then goes up to the North Pole, and then the water that is cold makes a convection current, and it comes down deep in the ocean where the water falls down. The hot water is on the top, and there's where your convection current happens. Now, what's important about the Gulf Stream is, and I'm going to go back and run it again, the animation. The Gulf Stream, if you think about the latitude, if you were in Russia at the latitude where England is, you would go over and you would live in Siberia. Does that sound like a vacation spot where I would want to move you to? No, when I talk about Siberia, you think of what? What's the climate in Siberia? Cold. England and Europe should be that cold. But what happens is the wind is blowing and it blows over the Gulf Stream. The warm water heats that air, and that air hits England and Europe and warms it up. It warms it up so that it is habitable and keeps it at a good temperature where a lot of our civilization has settled and comes from. And so without that current, it would be much, much colder. And so this current has been running for a very long time, because in our history, there have been people living in those areas for a very long time. Now, one idea and one theory about why Europe went under an ice age was that maybe that Gulf Stream current might have been affected somehow, didn't warm up the air, and that's what helped the area cool down and build up the ice. Again, not proven. It is a theory, but we're not exactly sure why the ice age happened. But right now, that movement of energy around actually keeps Europe and England habitable. And so the Gulf Stream is very important. Goes back to the Gulf, gets back in the kiddie pool, gets really warm, and then goes. And it continues to go for, and has been going for a very long time.